Welcome to Summarize Science. Today, we're journeying back to the cosmic dawn to understand the echoes of the very first stars. The James Webb Space Telescope is showing us the universe's earliest galaxies, but there's a huge blind spot. We can't actually see the individual stars that lit them up. These first stars were true giants, potentially hundreds of times more massive than our Sun. They lived fast and died young, creating the first heavy elements like oxygen and carbon, the building blocks of planets and, eventually, life. They also kicked off a process called reionization, which made the once opaque universe transparent, and they likely formed the seeds of today's supermassive black holes. The problem is, these original stars are long gone, so how can we possibly study them? Astronomers look for the next best thing, nearby dwarf galaxies that have very few heavy elements, or metals, making them perfect analogs for the early universe. This chart illustrates the cosmic timeline and how studying these local metal-poor galaxies is a path to understanding the past. But there's a major roadblock. Even in these nearby analogs, the most massive and important stars are so far away that our best telescopes just see them as a blended smudge of light. This plot shows the massive gap in our knowledge. The pink box is where the most critical stars are, and it's almost completely empty because we lack the technology to study them. One galaxy, called IZW18, is a particularly crucial target. Located 18 million light-years away, it's one of the most pristine star-forming environments we know, acting like a perfect local laboratory for the early universe. But its immense distance makes resolving its individual stars impossible with current technology. This is where the proposed Habitable Worlds Observatory, or HWO, comes in. Described as a super Hubble, this next-generation telescope would have the incredible resolving power to see what was previously a blur. This amazing simulation shows the difference. Hubble's view is on the left, while HWO's view on the right would turn that blurry patch into dozens of sharp, individual stars. By capturing the light from these individual stars for the first time, scientists could finally answer some of the biggest questions in astrophysics. They could measure the power of their stellar winds, which tells us how they enrich their surroundings with new elements. They could also determine their true temperatures and sizes, putting our fundamental theories of star evolution to the ultimate test. So, let's recap the main points. The first stars are a fundamental, yet missing, piece of our cosmic story. To understand them, we need to study their closest relatives in nearby, metal-poor galaxies, but we've been limited by technology. The proposed Habitable Worlds Observatory would have the unique power to finally resolve these individual stars, providing the ground truth needed to interpret observations of the early universe. This research represents a transformational leap, connecting the dots from the universe's first light to the elements that make life possible. Thanks for watching Summarize Science.